Hi guys, today I am going to teach you how to construct a confusion matrix or how to plot a confusion matrix for a deep learning network. Today what type of object I am going to classify and construct the confusion matrix means I am going to classify different type of leaf objects. So here I have taken different type of leaf object like leaf of type 1, leaf type 2 like that. So I'm going to classify this kind of leaf object with the help of Alex neural network. So I'm opening the Matlab, then I load all the data here, then I load the AlexNet here, I fix those layers, then I I'm doing the training here, then I check our input or doing the testing. Here I am checking the different input. So if you see here, I have taken test data. I have taken 5 data sets, test data. So I am going to check all those data and I am classifying those data. So here only I am getting my input, my output. Sorry, output. So this is the predicted output. So this is the confusion matrix. So here we are plotting the confusion matrix between predicted output and test data labels. So test data labels is nothing but this is the ground truth. It is already known what kind of leaf type this is, like that. So predicted means this is our AlexNet output of our input data. So this is the simple program only. So now I am going to run the program. So now it's running. The layer is processing and the training is going on. And testing is going on. Oh, now the output is displaying. So these are the outputs. I have given 25 images, so I am getting the outputs. So each output showing different classes. For example, if you see the first image, this is the leaf type 1, second image leaf type 4, third image 4, and second row you can see the leaf type 5, and third row leaf type 5, fourth row 4, 5, like this. This is our output. So these are the input and corresponding title is the output value. Also we are getting that confusion matrix also. So here you can see the overall accuracy is 64%. That means our system is 64% is accurately detected all different kind of leaves and 36% is wrongly detected. So now I am going to explain how to analyze this data from the confusion matrix. So x-axis we are writing all the different type of leaf, type 1, type 2, type 3, type 4, type 5, like that. In y-axis also we are taking like type 1, type 2, type 3, type 4, type 5. Now we are going to mapping this the type 1 with the type 5. So when we map this type 1 with type 5 means the value is, here we are getting the values as 0. So 0 means not a single input image is classified as leaf type 5. So the output value is 0. So if we check this type 1 with type 4 means there are 2 input is classified as type 4. So the output is so that we are getting the values 2 is here. Likewise, if you check type 1 and type 3 means 0, type 1 and type 2 also we are getting 0. So none of the input type 1 is misclassified as type 2 or type 3 or type 5. But 2 of the type 1 input is misclassified as type 4. And 3 input is classified as type 1. So from that, what information we can extract from this figure means how the first class is behaving with the all other classes. So if we check with type 1 to type means none of the classes are misclassified. So it is 0. 2 inputs are misclassified. That's why leaf type 4 is getting 2. That means 2 input are misclassified as leaf type 2 and 3 input are correctly classified as type 1. That's why we are getting 3 here. Then if we check this second column means what we are getting 60 and 40. So here if you check leaf type 2 versus type 5 means here we are getting 2. So what information we can see means 2 times the leaf type 2 is wrongly classified as leaf type 5. If we check with leaf type 4 means none of the input image is misclassified as leaf type 4 or classified as leaf type 4. Likewise, type 3 also we are getting 0. So there is no misclassification. When you check with the type 2, 3 times it's classified as type 2. So 2 times it's misclassified as type 5 and 3 times it's misclassified as type 2. Likewise, if you check the third one, type 3 to type 5, 5 times it is classified as a type 5. Actually the input is type 3 but it is misclassified as a type 5. But that, how many times? It's 5 times misclassified. Here misclassification is 0. Here also misclassification is 0, 0, 0. So when you check this type 3 to type 3, no input is classified as a type 3. All the input is classified as a type 5. So here we are getting 0. So leaf type 3 is giving the accuracy of 0%. Yes, no image is correctly classified as a type 3. All the image is classified as a type 5 times. So that's why we are getting the values 5 here. So when you check this one, when you check this type 4 to type 5, misclassifications, no misclassification, so the value is 0. Here you can check type 4 to type 4, 5 times it is classified as a leaf type 4. So 5 times it's correctly classified. Then 0 times wrongly classified, 0 times wrongly classified, 0 times wrongly classified. That's why we are getting the output as 100%. So leaf type 4 is giving the accuracy of 100% because all the type 4 input is classified as a type 4 input. That's why we are getting the values 5. So why we are getting the values 20 means we have taken 5 classes. So if you take the average of those classes means we are getting values is 20. So it is divided by 5. So 100 divided by 5 is equal to 20. So each class accuracy is fixed as a 20. Then when you see this row, this column, you can see type 5 West type 5 means 5 times is classified as a type 5. So this is correctly classified, 5 times correctly classified. And remaining the things also, when you check the type 5 to 4, 0 times misclassified, 0 times 0 times 0 times 0 times. So totally if you add the corner values, we are getting 64% and 36%. So this is the final accuracy. This is how we are analyzing the confusion matrix data from this confusion matrix. So from this we can identify how our system is performing based upon our accuracy or true positive values or true negative values. So for that we need to do the one-to-one mapping for each classes, type 1, type 5, 4, 3, 2, like that. So finally we are getting some accuracy value. This will show how our system is performing, whether it is performing good or bad, like that. So again one more time running, I am increasing the epoch value as 2. Now I am running the program. Now data is loading. Processing the layers. The training is going on. Now the testing is going on. Now the output is displaying. So yeah, now we are getting the confusion matrix. If we check this one, type 1 5 times correctly classified. So when we check the type 1 to type 1, the value is 5. Like that, type 2 also getting 100%. Type 3 we are getting 60-40. 60-40 means 3 times only correctly classified and 2 times wrongly classified as type 2. Likewise, 4 also we are getting 100. 5 also we are getting 100. Totally we are getting the accuracy of 92% because 8% is missing in the type 3. So likewise we can get the information from the confusion matrix. I think you all understand this one. If anything means you can contact me. So